Hey everyone, welcome to this tutorial. In this video, I'll show you how to build a fully functional CRUD interface using HTML, Bootstrap, and JavaScript. As you can see on the screen, we'll be creating a user management system where you can add, update, and view users, everything powered by a sleek front-end interface. We'll start by designing the layout using Bootstrap, making sure our page is responsive and user-friendly. After that, we'll link this front end with a FastAPI and SQLite backend, which we've already set up in a previous video. You'll learn how to fetch data from the API, display it in the table, and handle all CRUD operations seamlessly. Stick around, and by the end of this video, you'll have a fully functional CRUD application that you can use as a foundation for your own projects. Let's dive in. Hi again. We'll start by creating our HTML base structure. Begin with a simple layout that includes a title and a table. Here's the code. We'll start by including the Bootstrap link here. Don't worry about the code. You'll find all this code in the description. Just focus on understanding the logic. The div with container attributes will wrap everything inside a Bootstrap container, which centers the content and adds some top margin with MT5. We also have an H1 tag that will include a title at the top of the page, something like CRUD using JS, FastAPI, and SQLite to let the user know what this page is all about. Next, in our table, we have 4 columns: ID, name, email, and actions. The ID column will display the unique identifier for each user, which is crucial for managing updates and deletions. The name and email columns will show the user's name and email address, which are the main pieces of information we'll be managing in this CRUD application. The Actions column is where we'll place buttons for updating or deleting each user. For now, these buttons won't be functional, but they're important for laying out the structure. Here's the code for this table with some placeholder data. Notice how I'm using Bootstrap's built-in classes like TableStriped to make the table look a little more polished. The rows are striped, which helps users easily distinguish between them, making the data more readable. Now let's move on to adding a button that allows users to add new entries to the table. We'll place this button above the table, and we'll style it using Bootstrap's primary button style. Here's the code for that. This button is straightforward. It uses the BTN, B10 primary classes to get that signature blue Bootstrap button look. When clicked, it will open a modal that allows the user to input new data. Now, the modal is where things get a bit more interesting. This is the form that we'll use to either add new users or update existing ones. Let's build this modal together. Here's what's happening with this modal. The modal structure is created using Bootstrap's modal classes, which give it a clean and professional appearance. Inside the modal, we have a form with 2 input fields, one for the name and another for the email. These fields are required, meaning the form won't submit unless both are filled out. The Save Changes button will eventually be wired up to handle both creating new users and updating existing ones. We've also included a hidden error message, Alert Danger, that will display if something goes wrong when saving a user. This will help provide feedback to the user if there's a problem. Now, take a moment to review what we've built so far. We have a title at the top of the page. Below that, a responsive table displays our user data. There's a button to add new users, which triggers a modal form where users can input their information. In the next steps, we'll start connecting this front-end layout to our FastAPI and SQLite backend so we can start working with real data. This is where the magic happens, as we move from a static page to a fully interactive application. All right, now that we've set up our page layout, let's talk about something that's essential for making our page interactive: the API. API stands for Application Programming Interface. Think of it as a messenger that takes requests from our web page. The front end tells the server, the back end, what we want, and then brings the server's response back to our web page. Imagine you're at a restaurant. You, the client side, want to order a pizza. You tell the waiter, the API, what you want, and the waiter takes your order to the kitchen, the server. The kitchen then prepares your pizza, the data, and gives it back to the waiter, who brings it to your table. This is exactly how an API works, but instead of pizza, it's fetching data or sending data to be stored. Our applications process. Client side. Our web page. This is the HTML, CSS, and JavaScript that we've been working on. It's what the user sees and interacts with. API. Our FastAPI backend acts as the waiter. When you click a button on our web page, like adding a new user, the JavaScript code will make a request to the API. Server. FastAPI SQLite. This is like the kitchen where the data is stored in a database, SQLite. The API will either retrieve, add, update, or delete data in this database based on what the web page requested. So in simpler terms, our web page will send a request to the FastAPI backend, which will then communicate with our SQLite database to get the necessary data and return it to be displayed on the page. In the previous video, we built this RESTful API using FastAPI and SQLite. We created endpoints, like /users, that allow us to perform CRUD operations, create, read, update, delete, on our data. You will find the video link in the description. Today, we're going to connect this backend to our front-end page. Here's a quick overview of what we built. Endpoints. Our API has several endpoints, such as /users, where we can get a list of users, add a new user, update an existing user, or delete a user. Each of these actions corresponds to a different HTTP method: get, post, put, delete. Data handling. We used SQL Alchemy to interact with the SQLite database, allowing us to store and retrieve data efficiently. Let's now see how we'll connect this backend to the front-end layout we've created. We'll start by fetching data to display in our table. Let's connect the dots. Our FastAPI backend is like the engine of a car, and our web page is the dashboard where everything is controlled. First, let's start our server with the code we created in the last video. Open a terminal and execute uvicorn main app-reload. Then navigate to http:/localhost 8000/users. When you want to see all users, the front end will make a GET request to our /users endpoint. The API will retrieve all the user data from the SQLite database and send it back to the front end to be displayed in our table. I explained this in the previous video, and you'll find the video link in the description. Let's begin by writing the fetchData function that will call our API and get the list of users. Async await. This function uses async await to handle the asynchronous operation of fetching data from the API. The await keyword pauses the function execution until the API responds. Fetching data. We're using the fetch method to send a GET request to our FastAPI endpoint at /localhost 8/users. If we go to this URL, we will see a JSON object containing all users. Or if we use the Swagger docs of FastAPI and go to the Get Users route and try a test, we will see the list of users. The response variable will contain the response body from the server. The if not response.ok condition checks if the response from the server is not okay, e.g., 404 or 500 errors. If this is the case, an error of network response was not okay is thrown. Response.json. The response.json method parses the response body text as JSON, converting it into a JavaScript object. The result is stored in the data variable. This data will contain our list of users. Before we move on to populating the table with this data, it's important to understand what the data looks like. Let's print it out to the console to see the structure. Console.log data. Here we're using console.log to print the data variable to the browser's console. This allows us to inspect the structure of the data received from the API. Let's refresh the page. Oops, there's an error. Access has been blocked by CORS policy. No access control allow origin header is present on the requested resource. This error occurs because the browser blocks the request due to the same origin policy. Essentially, the browser is protecting you from making requests to a different domain, port, or protocol than your front-end page. This is a security feature known as Cross-Origin Resource Sharing, CORS. To resolve this, we need to enable CORS in our FastAPI backend. Here's how. First, install the necessary package by running. This package allows your FastAPI server to include the access control allow origin header in its responses. Update your FastAPI app to include CORS middleware. The CORS middleware is added to the FastAPI app, which specifies which origins, methods, and headers are allowed. In this example, it allows requests from any origin. Allow origins. which is suitable for development but should be restricted in production. Save the changes and restart your FastAPI server. Now, when you refresh your front-end page, the course error should be resolved, allowing the API requests to go through successfully. You should see an array of user objects. Each user object might look something like this. The data is an array where each element is an object representing a user. Each user object contains properties like ID, name, and email. Understanding structure. It's crucial to understand this structure because it will guide how we populate the table. Each user object will correspond to a row in our table, with the ID, name, and email properties filling in the respective columns. Once we've inspected and understood the data, we can proceed to use it to populate our table. Now that we have the data, let's clear any existing rows in the table and populate it with the fetched user data. Clearing the table. Before adding new data, we clear out any existing rows in the table by setting tablebody.innerHTML =, and let's remove rows from HTML as well. Creating rows. We loop through the fetch data using for each, creating a new table row for each user. Inserting rows. Each row contains the user's ID, name, email, and 2 action buttons, update and delete. Finally, the row is added to the table body with tablebody.appendChild row. Upon refreshing the page, the table should now display the users fetched from the API. For example, you might see users like John Doe and Jane Smith listed in the table. To ensure that the users displayed are correct, let's cross-check this data by directly navigating to the API endpoint in our browser. Open a new tab in your browser and navigate to h//localhost8000/user/. You should see a JSON array with the same list of users, such as John Doe and Jane Smith. This shows that the data we fetched on our front end is directly coming from our FastAPI backend. Another way to validate this is by using FastAPI's built-in Swagger documentation. Navigate to http://localhost8000/docs. In the Swagger UI, locate the /user/endpoint. Click Try It Out and then execute. This sends a GET request to our API. Compare the response. The server should return the same list of users that we see on our front end. This further confirms that our data is being correctly fetched and displayed. But what happens if something goes wrong? For example, what if the API is down or the network connection fails? We need to handle such errors gracefully. The catch block catches any errors that occur during the execution of the try block. This could be due to a network issue, a problem with the API, or an error in the code itself. We use console.error to log the error details to the browser console. This is useful for debugging. Now, instead of just logging the error to the console, we should provide some feedback to the user. Here's where we add an error label to our HTML. In order to display an error message if something goes wrong, let's add a new label in our HTML. This label will be hidden by default and will only be displayed if there's an issue fetching data from the API. Let's integrate that error label into our HTML code. This div element with id = error label is where the error message will be displayed. The alert danger classes from Bootstrap give it a red background to clearly indicate an error. The style = display none attribute hides this label by default. Now, Let's update our catch block to display this error label when something goes wrong. Show error message. If an error occurs, we update the inner text of error label to show a message like failed to load users. Please try again later. Display the label. We set error label.style.display equals block to make the label visible on the page. Auto hide the label. After 3 seconds, the error label will automatically disappear, ensuring it doesn't clutter the UI once the issue is resolved. Now that we've implemented the fetch data function, let's refresh our page. When the page reloads, you should see the users being fetched successfully from our FastAPI backend. Next, let's test if our error handling works correctly by simulating a situation where the API is unavailable. We'll do this by temporarily shutting down the FastAPI server and observing what happens on the front end when we try to fetch the user data. Go to your terminal where the FastAPI server is running and stop it. You can usually do this by pressing Ctrl+C if you're running the server locally. The server is now down, meaning our front end won't be able to fetch any data from the API. Refresh the web page where your front end is running. Since the API server is down, the fetch data function will attempt to send a request but will receive no response. This should trigger the error handling part of our code. You should see the error label, which was initially hidden, now displayed with an error message. This indicates that the API request failed. The error label is displayed because our catch error block in the fetch data function is triggered. This block logs the error to the console and reveals the error label to inform the user that something went wrong. If you open the browser's developer console, you can see the error message logged there. The console should display something like fetch failed, type error, failed to fetch, indicating that the request to the API could not be completed. If you want the error message to stay on the screen until the page is refreshed, you can simply remove the set timeout function. By doing so, the error label will remain visible until you manually refresh the page or hide it using other logic. The code responsible for hiding the label should be placed at the start of the function. Now, let's start the server again and continue our development. In this step, we will implement the functionality to add new users through the modal form. When the Add New User button is clicked, the modal form will be displayed. This is already handled by the Bootstrap modal. The form contains name and email fields and a Save button. When the Save button is clicked, the user should be created in the database and displayed in the table. We will create a function that will be triggered when the Save Changes button in the modal is clicked. This function will gather the user input from the form and make a post request with the new user's details. The API will then add this information to the database, return a confirmation that the user was added successfully, and refresh the table to include the new user. First, let's add an event listener to the Save Changes button. This listener will trigger the Add User function when the button is clicked. Now, let's write the Add User function, which will handle the form submission, send the data to the server, and refresh the user list. Gathering input values. The Add User function starts by collecting the values entered by the user in the modal's form fields, username and user email. Constructing the user object. A new user object is created using these values. This object will be sent to the server. Sending data to the server. The fetch function is used to send a post request to the server at http://localhost 8000/users. The user data is sent as JSON. Handling errors. If the server responds with an error, the catch block displays an error message inside the modal. This helps the user understand that something went wrong. Closing the modal and refreshing the list. If the user is successfully added, the modal is closed, the form is reset, and the user list is refreshed by calling the fetch data function again. Ensure that the fetch data function is invoked at the end of Add User to refresh the table with the updated list of users, including the new addition. Now, when you run the page, click Add New User to open the modal. fill in the user details and click Save Changes. The new user will be added to the database, and the table will automatically refresh to display the updated list. Oops, there's an error. If we check the terminal, we see the message, "Saw input should be a valid list." Let's look at our backend to find the issue. Yes, I see the problem. It's not exactly a mistake, but rather a mismatch in the response model for the user/post endpoint. We're trying to return a single user object, but the response model is expecting a list user response. To fix this, we'll change the response model in the createUser function to return a single user response instead. Let's make that adjustment and test it again. As you see, it works. Updating and deleting users follow similar patterns. The front end sends the request to the API, which processes it and updates or deletes the data in the database. Let's start by implementing the functionality to update an existing user's data. This involves writing a function that will populate the modal form with the current user data when the update button is clicked, and then send the updated data to the server when the changes are saved. First, we'll modify the table rows to include an event listener for the update button. This listener will populate the modal form with the current data of the selected user. Creating the OpenUpdate modal function. This function will be responsible for fetching the selected user's data, filling the modal form with this data, and then showing the modal. Since we're now using the same modal for both adding and updating users, we need to modify the addUser function to handle updates when a user ID is present. Populating the form. When the update button is clicked, the OpenUpdate modal function is triggered. It fetches the current user's data from the server using their ID, then populates the modal form with this data. This allows the user to see and edit the existing information. Handling updates. In the addUser function, if a user ID is present, indicating that the user is updating an existing record, the function sends a put request to update the user. Otherwise, it sends a post request to add a new user. Modal title and button state. The modal title is updated to update user to indicate the purpose, and the user ID is temporarily stored in the Save Changes button to distinguish between adding and updating. Error handling. If fetching or updating the user data fails, appropriate error messages are displayed to inform the user. When you click the Update button, nothing happens. The problem occurs because the query selector all button.update button only finds buttons that are present when the script first runs. Since the buttons are created dynamically after fetching data, no event listener is attached to them. To fix this, you can use event delegation. Instead of attaching event listeners to the buttons individually, you delegate the event to a parent element, like the table body, that already exists when the page is loaded. This way, when any update button is clicked, the event is captured and handled correctly. After these changes, you will be able to update a user's details by clicking the Update button. The modal will populate with the existing details, and after making changes, the user data will be updated in the database, and the table will refresh to show the updated information. Now we'll implement the functionality to delete a user. This includes writing the JavaScript code to handle the deletion process and adding a confirmation dialog to prevent accidental deletions. First, we'll modify the table rows to include an event listener for the delete button. This listener will trigger a confirmation dialog before proceeding with the deletion. Each delete button is assigned an event listener that triggers the confirm delete function with the user's ID. This function shows a confirmation dialog to ensure the deletion is intentional. Creating the confirm delete function. This function will show a confirmation dialog when a user clicks the delete button. If the user confirms, the delete user function will be called to handle the actual deletion. The confirm delete function uses the confirm method to display a confirmation dialog. If the user confirms, it proceeds with the delete user function. This step is crucial to prevent accidental deletions. Creating the delete user function. This function will send a delete request to the server to remove the specified user and then refresh the user table. The delete user function sends a delete request to the server with the user's ID. Upon successful deletion, it calls fetch data to refresh the table and reflect the changes. Error handling is in place to display a message if the deletion fails. With these changes, users can now delete entries from the table. The confirmation dialog prevents accidental deletions by requiring user confirmation before proceeding. After a successful deletion, the table is updated to reflect the changes immediately. That's a wrap. Congratulations on completing this tutorial. We've covered everything from setting up the front end and back end to implementing full CRUD functionality. In the next step, we'll be building a similar CRUD application, but this time using React for the front end. All the code will be available in the description below. If you're still with us at this point, drop a done in the comments and don't forget to subscribe for more great content. Thanks for watching and see you in the next video.